Hello and welcome to another video. In this problem, we're going to be working on unique length 3 palindromic subsequences. And in the problem, you're given a string s and you want to return the number of unique palindromes of length 3 that are a subsequence of s. Note that there are multiple ways to obtain it and it's only counted once. And this is a little bit tricky because we can't do our, I don't know if you see my other problem where you build palindromes, you can't just build from the middle. You can't just be like, okay, let's just start here and let's build it out from the middle. Because the problem is you can skip letters. So as you can see in these examples, you can take letters that are anywhere in the word. So you can't just build in a linear way. So in this first example, we have ABA, AAA, and ACA. And in the second one, there are none. And in the third one, there is BBB, BCB, and they show you here BAB and ABA. So the question is, how do we do this efficiently? And the way we're actually going to do this is relatively straightforward. What we're actually going to do is we're going to go through the string, and then we are going to get the leftmost and rightmost location of every character. So let's just say we have this string. And I actually brought this example up because I actually had a problem with this, and this was one of the test cases that I had an issue with because I was trying really hard to get a solution that wouldn't have to iterate through the string a bunch, but I couldn't really find a way around that. So we're going to do a few characters here. We're not going to do every single one of these, but we're going to do a few characters. So let's say we take the character D, for example, right? What we are actually going to do, our logic is we're going to go through the string, and then we are going to have two dictionaries. Now you can do it another way, but essentially we're going to have two dictionaries. So we're going to have one dictionary called left, and then we're going to have one dictionary called right. And the left will store the leftmost location of a character. So the character will be the key, and the location will be the value. And right will be the rightmost location. And so we can go through a few characters just to kind of see what this is going to look like. So let's take some characters that appear a bunch. Now, obviously, I'm not going to index this out, so we'll just make up some index just to kind of see how this works. So let's say we're going through this, and we reach this letter T at index 2. First, we're going to check, is that character in left? If it's not in left, then this is the leftmost location. So in that case, for the left, we'll call this left or something, left, we're going to add T and its index. So this index is 2. Then when we reach it again, let's say this index is 20. I'm just making this up. Then we're going to see, okay, if it's in left, then what we need to do is we need to put it in right, because the leftmost location is the first one. And if we already have it in there already, then we need to put it in right. So we'll add it to the right, T, and we'll make it 20. And then let's say we reach it again, then we can just override the rightmost index, right? The leftmost index is going to be the first time you see it, and then the rightmost, we can just keep overriding. So we'll see it, we'll override over here, and then we'll see it again, and maybe it's 30, whatever, right? So what I was trying really hard to do was, once I get these two, I was trying really hard to just get a letter, get the leftmost and rightmost index, and then see can I just check other letters, leftmost and rightmost index, and then can I check if it's in between them, right? So for example, if T has a leftmost of 2 and a rightmost of 30, I would just be okay, let me go through all the other letters and just check if the left or the rightmost index of that letter is in between here, then I have it. But the problem is there are a lot of cases where that's not like that. And so the case that I ran into that actually was an issue was, so let's say instead of storing T, I store the letter E. So the letter E will have some index here and some index here. So let's call this leftmost index 10, and let's call this rightmost index 30. The problem is T will have a leftmost index of 2 and a rightmost index of, let's call this 40 maybe. And so it will say that T is not in between here, but it really is, right? There is a T here. So the problem is if I just greedily take the new index and make it the rightmost index, there might be a T actually in between these E's that is a palindrome, but I'm not recording it. So we can't do that, because that would have made my code a lot faster, because then I wouldn't have to loop through the string. I would be able to just loop through the dictionaries. But anyway, once we get the left and the right, let's go back to this example. So for this letter, E, once we get the left and the right, so let's say it's 10, let's say 30, then all we have to do, and notice there's only 26 characters, and this is what we're going to take advantage of. There's only 26 characters, and we can get the leftmost and the rightmost index of every single letter in one iteration, right? So we can just loop through this and get the leftmost and the rightmost index of every letter. Then we will loop through our letters, and for example, for letter E, we'll say if left is so what do we need for a palindrome? We need 3 characters, right? So we're going to say if the character is in left, so we'll just like loop through all the characters in left. It has to be in right as well, right? Because a palindrome has to start and end with the same letter. So we'll say like if it's in left and it's in right, then loop through every character between the values and add those to a set, right? So essentially we're going to have a palindrome that's going to be like E, and then a bunch of letters here. And the nice thing is because we add them to a set can only have 26 letters. So let's say, obviously we're not going to go through all these characters, but let's say the set contains something like A, E, O, right? Then what do we do? Well, then for every single character in the set, we can make a palindrome with E and then the letter in the set and then E. So we can simply get the set of all the characters between, all the unique characters between, and we could say, okay, the number of characters, number of palindromes with E and then some character here and E is the length of the set. And we can do this for every single character, right? So we could say for E, let's loop through it. For A, let's loop through it. And the nice thing is, since there's only 26 characters, worst case scenario, we're basically looping through this string 26 times. In reality, not all the characters will be in left and right, and also we're not going to loop through the entire string, but worst case scenario, it's basically 26 times n, which is O of n. And we're also not storing anything big because the set is only 26 characters, right? The set is only 26 characters. This left and right dictionary will only have 26 characters. This is O1 space because this will be O1, this will be O1, this will be O1. That's kind of that's the logic for it, essentially. You get the left and the right most of every single character in one loop, and then after that you just loop from the start and end index of all those characters. You get all the unique characters in the middle, and then for each one of those, that can be a palindrome, right? So it'll start with some letter that's in the left, it'll end with some letter that's in the right, and then every single character in the middle can form a palindrome. And so that's what we're going to do. We're going to loop through all the characters in the left. We're going to say if it's in the right, then let's do this like set of all the characters in the middle, and then the number of palindromes we can make with those 2 characters is the length of the set, and the number of palindromes total is, let's take every single left character. If there's a right character, let's add up all these sets essentially. And so that's going to be our solution. So pretty straightforward. I did try to make it better. Like I said, I wasn't able to do it. So if someone is able to make it with just using the dictionaries, that is kind of cool. But yeah, the problem is like, in order to do it, at least the way I see it is like, you'd have to store the location of every single letter, and then that becomes kind of expensive, right? So if there's like a bunch of T's, you'd have to store the location of like every single T and check like if any one of them is between those, and then you're kind of like basically looping through your string. So it's like also your space will not be O1 in that case because you're going to be storing the location of every single letter, which would be O1 space. So this is, I think, as good as it gets for this one. So let's actually code it up. So we're going to have this like left boundary dictionary and a right boundary dictionary. And yeah, I was trying to debug it for a long time, and then I realized my issue was, yeah, like the reason I can't check if the left and the right boundary is in between other ones is because it might be at first, but then I update it, so then it's not. So it took me a while to realize I couldn't do that. So essentially, we're going to loop through our string. So we'll just say like for I char in enumerate s. So we'll say if the char is in left, then this has to be the rightmost boundary now, right? So we're just going to keep updating our rightmost boundary to this. So we'll say right char equals I. Otherwise, if we've never encountered it before, this is the leftmost boundary. So now that we have the left and rightmost boundary, we can actually go through all of them. So we'll say for character in left. So it has to be in left and in right to make a valid palindrome. So if character in right, then let's just take all of the letters in between those and then every single letter in between those. So let's say like we have A in left and in right. We'll just say, okay, we'll have those indices and every single character in between those we'll throw into a new set. And the length of that set is the number of palindromes because they will have A as the left and A as the right and then some character in the middle. For example, if the character is A, and we do that for every character that we have. So we'll say character equals set. And for I in range left character plus 1, because we don't want to have it inclusive, we want to have it between these. So between these, we just do this, we add it to the character set, and simply the number of palindromes starting and ending with that character is the length of this set. So result plus equals length of characters, and we can return the result. All right, let's take a look. fine. So there we go. And about an average solution. I think most people are going to have like an O of n solution. So for the time, it is O of n because we're basically looping through the string once here. And then we are looping through the string once for every single character, but there's only 26 characters, so it's like 26n. So this is n. Space is O of 1 because the left and right only have 26 characters, so they're capped at 26 characters, so that's O of 1. And same thing with a set, it can only have 26 characters because you can only have A through Z. And yeah, it's going to be all for this one. So if you did like this one, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.